summer is not done yet. It is unexpectedly warm today. So I was having a couple of conversations not too long ago that seemed to dovetail. I thought, what a cool video opportunity. Conversation number one with my dad, where he asked, what is it that you guys do at Nutanix? So I started to describe the elimination of management silos, operational simplicity, etc., and then showed him our standard first call PowerPoint deck. The deck made it make a lot of sense to him. In another conversation around the same time frame, one of my storage focused friends started talking about technology and describing for him what Nutanix is all about, and for him, obviously being in IT, a bit more relevant than it was for my dad, but it was interesting dialogue with him really being into storage. He's got a ton of experience with different platforms from HP and NetApp and all the usual suspects. But he's used to turning over the zoning responsibilities when it comes to presenting storage to the network or the storage switching guys, right? So I was thinking, let me walk him through a day in the life of the storage admin when Nutanix is involved. And so that's kind of the inspiration for this video. And so we'll show you what it's like for the storage operator to provision storage on the Nutanix platform. And in this example, we're going to use a Linux workload. Could just as easily apply to a Windows-based solution. So check this out. And I think I'll break this into multiple parts. We'll start with storage administration under Nutanix with a little bit of Linux admin as it relates to that storage operation. And then maybe we'll take it into some more in-depth topics. But in any event, hope you enjoy. Like, subscribe, turn on post notifications so that you are alerted anytime I post new videos. Make it a great day. Here in Prism Central, you can see that I have a couple of clusters registered to Prism Central. I also have a few consoles open, and for this demonstration, we'll focus on this one. First, I'll show you that this particular VM, if I can type, only has local storage provisioned. And that is the only thing mounted at this point. So we'll want to focus on storage activities here in the Prism operator experience. I'm going to go over to this cluster. And I want to first highlight, we've got all the pertinent details here on our dashboard. You can see the health and well-being of everything that's happening in the cluster. I want to go over to storage, and you can see that I've got a couple of volume groups configured. Super easy to set these up. In fact, if I wanted to create a new one, click on volume group here, go ahead and give it a name. I can add a new disk. size it up. Can add another one. And add another one. So you see how simple this is. This is very much akin to what storage administrators have become accustomed to, calling it carving up LUNs, if you will. We'll go ahead and enable external access. Yes, with the Nutanix platform, systems that are outside of the platform can look to this storage as an iSCSI target. We'll go ahead and save this. The save button is just off screen here, so you can't really see it, but I'm going to go ahead and do that. And you can see I've got my test data store here. Super easy to create these storage repositories. But what I would like to do is I'd like to present this volume group to this virtual machine. So I'm going to go and update this volume group. You can see I've got a number of 800 gig disks in this volume group. And what I want to do is add a new client. So I'll go ahead and do that. Let's see, what is this guy's IP address? 7550. Go ahead and add. And we will save that. All right. And over here, this is going to be an iSCSI initiator, so I want to talk to that target. So what we'll do now is I'll say iSCSI admin, discovery mode, session target, and my data services IP for the Nutanix host, or cluster I should say. It should be 38. Let me verify. Yep, 7538 is my data services IP. So that's good. And while we're at it, we'll go ahead and log in as well, right? Gotta be able to type it correctly. All right, so we've discovered disks available to us on that target, and you can see that we've also successfully logged in. So now, if I clear this and we look at connected block devices, let's pause right here. So let's quickly take stock. You just watched a process that in the old days would take countless people, numerous interfaces, and even more time to deliver a resource to the requesting entity. You saw this done in just a few minutes in the same interface that the virtualization team would use, which is the same interface that the networking team would use to handle uplinks or virtual networks for virtual machines. One operator experience, complete consistency, operational efficiency. With the storage provisioning complete, we'll now take this session a few steps forward just to have a little bit of fun. And we now have new block storage devices available to us. So what I'd like to do now is create partitions on these guys. But obviously, or maybe you're not so obvious, but I'll tell you, I'm not really interested in interactively going into fdisk and dealing with each of these partitions. So let's invoke a little bit of bash magic to help us out with this task. So we'll write a little for loop here. B, C, D, E, F, G. All right, so we know that when we are in fdisk, we want to do a sequence of events. So first we want to create a new partition ID. So we'll do the letter O, hit enter. We next want to create a new partition, hit enter. We then want to set that as the primary partition, hit enter. Partition number will be 1, hit enter. And then for the next two values, we'll accept the defaults, hitting enter there. And then we want to change the partition type, hit enter. The type is going to be an LVM. Once we've done that, we'll hit enter here, and then we will write our changes to the disk. We'll take those key sequences and we will send them to fdisk, if I can type. And let's see, how did we do? All right, cool. And we now have partitions on each of those disks. Now we are in a position to create physical volumes. So I'll go pv create. And I'll use wildcards here. We want B through G. And then with those physical volumes created, I'll go ahead and create a volume group. Giving it a name. Seems good enough. And we're going to use wildcards again here. B through G. All right, so we have our volume group. Do a VG scan. We see our VG data store is in place. And so now what we can do is go ahead and create a logical volume made up of all of those slices of disk. And to do that, I'll do a LV create. I'm going to give it a name. Let's see, DB info. Size it up, say 200 gig. Let's make it 300 gig. We have a number of disks here, so 1, 2, 3, 4, 5, 6. We've got 6 disks here, so we want our stripe to exist across all 6 disks. And let's assume that we were going to be running MySQL and storing the database information on this disk. By default, MySQL databases have a page size of 16K, I believe. So we'll align the stripe size with that here. And then I'll specify the volume group on which I want this logical volume created. All right, and so our logical volume is now created. If I clear the screen, take a look at the disk now, we can confirm that we created partitions on those disk slices, created a volume group, and then subsequently created a logical volume all across those disk slices. And this sets us up to be able to put a file system on this guy. So maybe MKFS, we'll use the XFS file system, and we're going to do /dev/ VG data store /db info. Thinking. And now we have our file system. And I can go ahead and mount that. Let me make a directory. And then mount that guy. On DB data. So now we see we have our 300 gig volume mounted on DB data. And life is good. Now, what if we want to have this volume automatically mounted whenever the machine restarts? Well, that's not too difficult. I'm going to clear the screen here. And I want to get the UUID associated with our new volume. So I'll do a list block storage. I'm going to do a -O. I want the name and the UUID. All right. So I'm going to put that in a file. And then what I'm going to do is edit the file system table. And the objective is going to be to modify it so that when it's read upon startup, this volume gets mounted by default or as a part of startup. So let's, do I have Vim on this guy? Do not. So let's install Vim really quickly. All right, so we've got Vim installed. Now I want to edit both the file system table and that file that I just created containing the disk information. So I'm going to go down and add a line, UUID equals. Then I'll move over to the second file, and I want to get the UUID for our new disk. And you'll notice that for each of the, you've probably noticed by now, hopefully, that each of the slices here have the same UUID. So it is sufficient to just copy one of these guys. Take this one, yank that, go back over and add it to the end, and then we'll just modify this. What did we say? DB data, I think it was. The file system type. Now, this is a network device, so we don't want it to be subject to the same rigor that locally attached storage is subject to. So we're going to specify, while this is the XFS file system, we want to let the OS know that this is a network device. And I do not want a backup, nor do I want a file system check run on it. Automatically anyway. So I will save both of these. We will go ahead and restart to make sure that once this comes back up, we do see that our file system is automatically mounted. So this will be up in just a moment. And we're back. So go ahead and log in. Oops, I messed that up. All right. Take a look at our mounted devices. Drum roll, please. And we see that we have an auto mount on DB data. Looks good. And so I mentioned that we were going to assume that this machine was being prepared for MySQL. How would we go about ensuring that MySQL used this new storage repository as its database location? Well, we know a few things about MySQL. We know that, one, it stores its data by default in var lib MySQL. We also know that it creates an additional folder, var lib MySQL-files. So prior to running the MySQL install, let's do a couple things. First, within the DB data folder, which is now mounted on our iSCSI storage, let's create a MySQL folder. And then let's also create a MySQL files folder. With those things in place, we can create on var lib symbolic links to MySQL and MySQL files by simply doing a link symbolically. We're going to have MySQL live on MySQL and var lib, and similarly do another symbolic link and have MySQL files live on var lib MySQL files. And now we can confirm that by listing var lib. We see that our symbolic links are in place. And so now when we install MySQL, start it up for the first time, it will use those symlinks and subsequently store its information on our newly provisioned storage serviced by Nutanix. Thanks for taking a few minutes to check out the content on the channel. If you enjoyed that, please click the like button, subscribe to the channel, turn on post notifications so that you get alerts anytime I post new content. Thanks again for watching. Make it a great day.